Hi everyone, good morning. Welcome back.
Good morning, sir.
Yeah, so last 3 sessions we have completed. So DevOps demo, DevOps introduction, question and answers, and cloud introduction. So what is cloud? Why cloud? Why the project teams are looking for cloud? Why the infrastructure is migrating to cloud? Right? So what is cost saving? What are the advantages? We discussed, right? So from today onwards, regular sessions like so first 2 days, today and tomorrow, we work on servers and networks basics, right? So before going to cloud, first we need to understand servers, networks, IP address, subnet mask, gateways, routers, load balancers, right? So these are all very important things, very important concepts, basics, right? So if you understand this, you can easily understand cloud concepts. Fine. Yeah, first 2 days we work on this. After that, so how to create AWS account, how to connect AWS console. So we'll walk through the console. What are the services available in AWS, right? So how to create infrastructure in AWS. So as a DevOps engineer, we have to create infrastructure as well as we automate the activities, right? So currently no admin roles are available in real projects. So admin is already gone, right? Yeah. So going forward, admins will not be available, right? Admins will not be there. So that is why, as a DevOps engineer, so we have to create infrastructure as well as we have to maintain the infrastructure, and we work on automation activities. Fine. Yeah. So today's agenda here is what is server, types of servers, server client model and best practices, server architecture, what is operating system, types of operating systems, right? So what is network, types of networks, what is IP address, subnet mask, gateway, router, firewall, load balancer, failover, right? So these are the things we are going to cover. So today up to here, up to operating system we can cover, right? This will take 1 hour. So yeah, so today, tomorrow, and Wednesday, only 1 hour session. So Thursday onwards, 1.5 hour. So make sure we need to cover 1.5 hour because we need to complete within 2 months, right? Yeah. Fine. So basically, what is server? What is server? Anyone? What is server? Fine. So I found some definition. I found definition from Google. So a server is a computer that serves information to other computers called clients. Client means desktops or laptops, right? So a server is a computer that serves information to other computers called clients, can connect to a server through either a local area network or wide area network such as the internet, right? So what is network, what is local area network, what is wide area network, we'll see that. Okay, yeah. So server is a main computer of the main computer in the data center, right? So it serves requests. So when you send any request, server will give response, right? Yeah. So whatever applications developed by developers, those will be directly saved into the server one. Server will have high computing power, right? So high memory, high CPU, high storage, right? Yeah. These servers can be hosted in data centers. What is data center? We know, already discussed. Data center is a server node, right? Yeah. So every developer, every tester, every DevOps engineer, they direct before working on any activities, they directly connect to the servers before performing any activities, right? So directly connect to the server. In the server only, they can store the data. They can access the data from server, right? Yeah. So types of servers. What are the types available? So these are the 3 types of servers available in the data center. So first one, can you mute everyone? Some background noise is coming here. Yeah. So these are the 3 types of servers. First one is blade server. What is blade server, right? So we'll see that. Rack server and tower server. blade server, rack server, and tower server, right? So three types of servers are there. So what is blade server? We'll try to understand first. So a blade server is a modular server that allows multiple servers to be hosted in a smaller area. So it's just like a container. In this container, small units you can insert into the container. So these are the thin servers. We can say thin servers. So basically, these servers will be used in enterprise level data centers, right? So these are high performance servers, bit costlier compared with traditional servers. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. So these servers are physically thin and typically only have CPU, memory, integrated network controllers. Some servers storage drive is also built in. So basically, this thin servers will not have any storage, right? So, but how can they store the data? How can the developer store the data into thin servers, blade servers? Backend external storage will be attached to the thin servers, blade servers, right? So blade servers are often seen in large data centers, like enterprise level data centers. We use this. Fine. So these are the blade servers. Next one, rack servers. So a rack server is a server mounted inside of a rack. So these are the traditional servers, we can say. Rack servers are typically general purpose servers that support a broad range of applications and computing. So most of the data centers, they use rack servers only. These are the general purpose servers, right? So in this racks, in this racks, we can insert servers, we can connect power network, we can configure, we can move to production, and we can use. These are the traditional servers. Okay. So next one, tower server. What is tower server? A tower server is a computer that built in an upright cabinet that stands alone, and that is designed to function as a server. So this is bit older server. Tower servers are bit older servers. So in single tower, one server only we configure, and this tower will have one monitor, one CPU, one keyboard. These are the bit older servers. Currently, we are not using this. Currently, we are not using tower servers. So currently, we are using rack servers, blade servers in real-time projects. So even though this rack servers, blade servers also, so we are not using currently. So because the servers are migrating to cloud, we are migrating to cloud because cost saving, right? Very few project teams, few data centers, they are using physical servers. So maybe going forward, after 1 year, after 2 years, you don't see any physical environments. All the applications we are hosting directly cloud servers. Fine. Next one, client server model. So this is server. These are the clients. Through network, we can connect our servers, right? So when you send request, so server will give response to the clients. Fine. So every developer, every tester, they connect directly to the servers through network, either local area network or wide area network or Wi-Fi, internet, right? They can connect, they directly work on servers only. They don't develop any code on local systems. Okay. So this is another model, client server model. So these are the clients, these are the servers. Through internet, we can connect our servers, right? Next one, server architecture, right? So server architecture is the foundational layout or model of server. So based on which a server is created and are deployed, right? It defines how server is designed. Okay. So here I give you few examples. Okay. Server architecture in first phase of implementation, initial phase or stage. Initial phase of implementation. So this is first phase. initial phase of implementation. This is first phase. Okay, so in 90s and early 2000, how the server architecture, how the project teams are used to configure servers, right? So in 90s and early 2000, right? So 22 years back, right? So how the server architecture? So because this is very, very important, first phase of implementation, initial phase of implementation, how the server architecture. So for example, we have 4 applications are like Java, Git, Maven, and Jenkins. So four applications are there, 4 different applications. So in 90s and early 2000, when the project teams wanted to configure the servers, they used to take one application, one server. For each application, they used to take separate server, right? Yeah. For example, we have 4 applications are there. So project team project team configured 4 servers here. These are the 4 servers. So by the time in 90s and early 2000, highest capacity of the hardware is highest capacity of the hard drive is 1 GB only. By the time 1 GB storage. So these are the 1 GB servers. Right? Yeah. So here in first server, Java configured Java. So Java will take minimum 400 MB, for example, 400 MB. So remaining space, 600 MB space will be wasted right here. 600 MB. So next one, Git. Git will take, for example, 300 MB. So remaining space will be wasted, which is 700 MB will be wasted. Maven. So Maven will take 500 MB, for example. So remaining space will be wasted here. Jenkins. Jenkins will take 600 MB, for example. So remaining space will be wasted. Right. So every application they used to take separate server, one server, right? So here, so by the time in 90s and early 2000, hardware costing it was very higher, right? Even desktop also 1 lakh, 2 lakh, like that, right? Yeah. So by the time project teams used to spend more costing for servers, right? Here utilization is very less. Server utilization is less, costing more. That is why this model is failed. This concept is failed, right? So this concept, by the time, most of the companies they used to use hardware, right? So this hardware will work only 5 years. After that, they decommission, right? That is why so project teams used to spend more costing for the servers hardware. So that is why this is a failed concept. This concept is failed, right? Yeah. So after that, after 2000, slowly, yeah, second phase of implementation. In second phase of implementation, so project teams used to take higher capacity server. They used to take one higher capacity server. They used to deploy all the packages on same server. All the packages, whatever, like Java, Git, Maven, Jenkins. Java, Git, Maven, Jenkins, right? So here, what will happen? Java user may access Java application, Git user may access Git application, Maven user may access Maven application, Jenkins user may access Jenkins application, right? So all the applications are hosted on same server. All the users connect to the same server, right? So here what will happen? So Java user may access Git application also. There may be chances because all the applications are hosted on same server, all the users are connected to the same server. So there may be chances to access other users, right? So Git user may access Maven application. Maven user may access Jenkins application. So security will be there. Still, there may be chances to access. That is one drawback. For example, 4 people are staying in one flat. 2 people are in one bedroom. 2 people are staying in other bedroom. The 4 people may access commonly kitchen and dining room. The same way, so when we host different applications on same server, so all the users can access, there may be chances to access, right, to the applications, all the applications. This is one drawback. And also, if the server is crashed, what will happen? All the applications will be gone, right? So that is why this is also failed concept, right? Yeah, slowly, in third phase of implementation, we started using virtual servers, virtualization. Right? Yeah. So when we talk about virtualization, we can easily, understand that VMware, Citrix, right, hypervisor. These are all virtual layers, right? So in a virtual environment, what we will do, we take one physical server. On top of that, we create virtual servers, right? Yeah. Now, so we take one physical server. This is physical server. This we can say base OS, base operating system, right? Yeah, on top of this, what we will do, we install one layer which is VMware or hypervisor, Hyper-V, or else Citrix. So this is virtual software. This is software. So once we install this software on the base server, this will allow you to create virtual servers, right? Yeah. So on top of this, what we will do, we can create virtual servers. How many servers you require, you can create. As per the physical server capacity, we can create virtual servers. These are the virtual servers. So different operating systems you can install on different virtual servers. Like here I can install Windows 2016. Here I can install RHCL, Red Hat Enterprise Linux. Here I can install SUSE Linux. Here I can install Windows 2019. Here I can install Ubuntu. So different operating systems I can install on different virtual machines. So this virtual servers will take resource from where? This virtual servers will take the hardware resources from physical
Base
server
OS.
only. Physical server only, right? So this is a physical server. So physical server will have higher capacity of the hardware, right? So normally when we configure VMware servers, virtual servers, physical server required higher capacity of the hardware. So here RAM 48 GB, CPU 32 core CPU, and hard drive We can use 10 TB like this, right? So this is higher capacity server. So this server will share the resources to virtual servers, right? Yeah. So based on the capacity, physical server capacity, we can create number of virtual servers, right? Yeah. So here still we are using virtual servers in real-time projects, but here also we have some drawbacks. What are those? What are the drawbacks? Yeah, go ahead, please. Yeah,
Uh,
someone asked me some question. Yes.
that VMware or hypervisor, they are softwares, right? So they will require one operating system, or how will that get installed?
Right, right. Yes. So this is a virtual layer. This is virtual layer, virtual software. So on physical server, for example, this is physical server. In this, we install one operating system like Windows or Linux, whatever. So on top of that, we install VMware, right?
Okay.
So this
Okay.
VMware, yeah,
And this base operating system will not be used by the VM machines that we are creating on top of that.
right, correct. So
Okay.
this is bare metal server, physical server. So in this, we install VMware or hypervisor and Citrix, right?
Hmm.
Clear, right? Kumar, I think.
Yes, yes.
Yeah, so this VMware will allow you to create virtual servers, virtual different servers, right? Yes, fine. So still we are using this servers in real-time projects, but still we have some issues with the servers, this virtual servers, right? So currently we are using virtual servers, but we have some drawbacks, so many issues, right? So when you want to configure this virtual server, we use ISO image. What is ISO image? What is ISO? Anyone? Yeah, International Standardization Organization. This is a one image master copy, right? So if you want to install Windows in your laptop, what we will do? We use some image, right? So the same way, server side also we use image, which is ISO image, right? So this ISO image size would be minimum 6 GB to 18 GB minimum. So when you want to install any operating system on virtual server or physical server, we use ISO image, right? So for example, if you install Windows 2019, it will take 15 GB, right? If you want to install Ubuntu, it will take 8 GB. If you want to install RHCL, it will take 10 GB. Like that, different operating systems, they take some space for operating system, operating environment, right? For example, here we have 5 into 5, 25 servers are there, virtual servers. So on an average, each server will take 10 GB, 10 into 25. So it will take 250 GB for only operating system. On top of that, again, we have to install Java, Git, Maven, Kubernetes, whatever we require. So we have to install patches, updates, configurations, right? So it will take use space, right? And also, when you want to restart this physical or virtual server, when you want to restart, why we need to restart servers? When you perform any major activities like deployments, right? Any configuration changes, make sure that server should be restarted. So when you restart any physical or virtual server, minimum it will take 4 minutes to 8 minutes. When you restart any physical or virtual server, will take minimum 4 to 8 minutes. So it will check memory, updates, then it will restart, right? So this much of time client will not accept, client will not wait, right? So that is why this is also one more drawback. So downtime. So when you want to get any downtime, what is downtime? Anyone? In real-time projects, when you want to get any downtime,
When the servers are not available.
right?
Restarting the
Downtime is
servers.
restarting the servers, right? Fine. So downtime means maintenance time, right? So when you want to get any downtime, so we need to talk with the client and the management, right? So they will not approve sometimes. They will ask justification. So why we need to go with the downtime? Why we need to down the server? So if you down the server, business will be impacted, right? So many roadblocks. You want to get any downtime, so you need to discuss in the calls, you need to shoot some emails. So client will ask for justification, we need to provide the justification. Finally, sometimes they will approve, sometimes they will not approve. For example, so we hosted one application on server, virtual server, like Flipkart. Flipkart hosted on the virtual server. If you down the server, Flipkart application will be down, right? So Flipkart, we can, yeah, people will access through, people will access globally, right? So if you down the server, if you down the application, business will be impacted, right? So the same way, clients, different applications, client application, different applications we deploy on servers, right? So that is why client will not accept sometimes, right? Yeah. See, in my previous project, in our previous project, last 5 years we haven't down any server, Linux servers. Those are critical production servers. We haven't down last 5 years. Still they are working fine without any issues. But sometimes some issues will be happen, crashes will be happen. So whenever we deploy, whenever we perform any activities, make sure that server should be restarted so that updates will be, yeah, whatever updates we install, that will affect to the applications or operating system, right? Yeah. So these are the drawbacks. So when we want to install operating system on virtual server or physical server, we use ISO image. The size would be higher. It will take higher storage, high capacity storage, like 10 GB, 20 GB, like that. And also, when you want to down any server, so minimum it will take 4 to 8 minutes, right? So client will not accept this much of time. And also deployment time, deployment and downtime is high, right? So deployment time, what is deployment time? So when you want to deploy
installing
any
the
application,
software in the
yes,
server.
deploying applications, deploying code, right? So this will take some time. Deployment also will take some time in the servers, right? So these are all drawbacks in virtual environments, virtual servers, right? So speed we are using, but these are all the drawbacks. That is why project teams are looking for advanced environment, which is Docker containers. Currently, project teams are looking for Docker containers. Docker containers are very advanced to virtual servers, right? So let us go and discuss about Docker architecture, right? So this is fourth phase of implementation, right? So currently, most of the project teams are migrating to Docker containers, right? Yeah. So in this Docker architecture, same as virtual environment, we take one Docker server. This is Docker server. So this server can be physical or virtual or cloud, any server. You can take this. On top of this, we install or configure Docker image. We configure Docker image. So this Docker image will allow you to create Docker containers. These are the Docker containers. right? Yeah. So here we can deploy different operating environments, different operating systems. These are all containers. We can deploy different operating systems like, so here Ubuntu, CentOS, RGL, even Windows also, right? So different operating system we can install on different containers, right? So when we run any container, when we deploy any operating system, when we run any container, only lib and bin files will be installed. On containers, only lib and bin files will be installed. Library binary files. Okay. So when we run any container, it will take only 200 MB, 200 MB of this size. It's a lightweight environment compared with virtual servers. This is very lightweight, right? Yeah. So, and also when you restart, when you want to restart any container, it will take 15 seconds only. Within 15 seconds, this container will be restarted, right? Yeah. So currently we are accessing some digital sites. Currently, when you want to book any products, we access Flipkart, Amazon shopping site, Mintra, right? Misho, different sites are there. Those are digital sites. Even though for groceries, we are using Dunjo, Japto, right? So when you book any products, within 10 minutes also, they are delivering. How can they deliver within 10 minutes? Because backend they are using containers, Docker containers. It's very faster. Very when you execute any request, when you place any order, within few minutes, that will be processed, right? So, for example, yeah, in lockdown time, everyone used online only because Docker containers. Currently, digital sites are very popular. So online shopping, right? So when you place any order, within minutes it will be placed, right? So recently I booked one mobile, which is OnePlus mobile, right? Within 4 hours they delivered. Within 4 hours, right? So OnePlus mobile. So basically that will be stored in somewhere like local storage, local agency. Within 4 hours they delivered because backend Docker containers, right? So it's very faster, very advanced. So here in Docker containers, when we run any container, when we configure any operating environment, it will take only 200 MB. So lightweight environment. So when you restart this container, 15 seconds only. So, but here we don't use any ISO images, right? It is a very lightweight environment. And also here deployment time and downtime is less, very less, right? So when you deploy any applications on Docker containers, it's very faster. Within minutes will be deployed. So when you want to when you want to restart any container, within 15 seconds, even though we are working on the container, they don't understand whether the container is restarted or not. Very faster, right? So that is why project teams are looking for Docker containers. This is very, very advanced concept, right? So while working on Docker, we'll go deep dive. Docker will take 7 hours. In our sessions, Docker will take 7 hours. So Kubernetes is advanced to Docker. Kubernetes will take 8 to 9 hours. We'll go deep dive, right? Yeah. So currently, so project teams, they are migrating to Docker containers because of less deployment time, less downtime. So client always look for what they will look, time saving, and measure one, cost saving. Compare with physical servers or virtual servers, Docker containers are very less costly, right? So Docker containers are 1/4 cost. When we use Docker containers, so compare with physical environment, this is 1/4 costing, very less costing. So very faster, time saving, right? So that is why whatever applications they are hosting currently, they are migrating to directly Docker containers, right? They are hosting on Docker containers. Fine. Any questions, anyone up to here?
So in current scenario, do we using this virtual servers?
Still we are using, but slowly, applications are migrating to Docker containers. So maybe after
So
1 year, any physical environments.
maximum we are avoiding this virtual servers, right? I mean, so many project
Yes,
years.
yeah. So in our project, 4 years back,
Okay.
in our data center, we used to use 1,000 servers. Currently, 50 servers only we are using. Why this much of drastic change? Because Docker and Kubernetes, we are migrating to containers. So containers are advanced virtual servers. Container is not a server. It is just like box. In general, container means box. We can move anywhere, we can use anywhere. Lightweight environment. So while working on Docker, we'll go deeper, right? So Docker is very advanced one. So if you are good in Docker, only Docker, you can easily crack your entry. If you are good in only Kubernetes, you can crack easily. You can crack your entry, right? Yeah. So Docker, Kubernetes, these are very advanced concepts.
So I had a one question on the VMware.
Hmm.
So for presently, some of the clients were for the employees who were been logging, right, for external employees. So for them, they are creating the VMwares, right? Is they are using the for that for means for the desktops, everything they are creating the VMware. So for them also, they are going to use Dockers or only the virtual servers only creating for the virtual desktops.
Laptop, desktop use same. Either laptop or desktop use. But server side I'm talking about. Servers would be, yeah, whatever applications we are hosting on server, those will be migrated to containers. We directly connect to the cloud containers.
Okay.
You don't require
Yeah.
any physical environment, right?
Okay.
So because, yeah, client always look for the cost cutting.
Okay.
Fine.
Thank you. Yeah. Thanks.
Any other questions, anyone?
So if we deploy the application in the Docker thing, so we don't need to rerun the server.
You don't require, right? Physical service not required. You can
Okay.
connect your cloud environment. You can create Docker server. On top of that, you can run container. You don't require any
Only
physical
that
environment.
particular container we rerun instead of that whole server.
Correct. Yes. Instead of hosting on the server, you can directly host on Docker container. This is
Okay.
very faster, lightweight environment, right?
Okay.
Fine. Next one. So this server architecture, again, while working on infrastructure, AWS services, we'll go deep dive. Okay. So this is server architecture. We'll go deep dive, right? Yeah. Next one. What is operating system? What is operating system, anyone?
It's a collection of code which is used to connect with the hardware. So it's a communicator between us and hardware.
Any others? Right. Yes. Fine. So operating system is a interface between user and the computer hardware. Right? It is a interface. It is a mediator. So hardware always understand the binary language, binaries, zeros and ones, 000, 001, 100, 111, like that. So hardware understand only binary language, but a human will not understand, user will not understand binary language. That is why we require some mediator, which is interface, right? Yeah. See here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones, right? So in such case, we need an interface which can translate human language to hardware and vice versa for effective communication, right? Operating system will translate binary to human readable language and vice versa, right? See here. So this is an operating system. It will convert binary language from hardware to end user and vice versa. Next one, types of operating systems. What are the types available? First one, single user, single tasking operating system. In this type of operating system, only one user can log into the system and he can perform only one task at a time. For example, this is MS-DOS, Microsoft Data Operating System. In this, only one user can log into the system. He can perform only one task, right? Yeah. Second one, single user multitasking operating system. In this type of operating system, only one user can log into the system and he can perform multiple tasks at a time. Multiple tasks. For example, Windows. So while working on, like while browsing internet, we can run background audios. While working on paintbrush, we can run background audios, right? Single user can perform multiple tasks at a time, which is Windows, right? Next one, multi-user multitasking operating system. So in this type of operating system, multiple users can log into the system. They can perform multiple tasks at a time. So for example, Linux and Unix. In real-time projects, most of the servers we use Linux only, right? So Windows servers also you can configure, but very few servers. But 99% of the servers we use Linux only. So why we use Linux in real-time projects?
It's a
What are the
faster
difference
and
here?
faster. It's a free to use. Need not to buy the operating system, and it's a faster than the Microsoft.
Right. So main thing here is security. Security, right? So Linux is more secure compared to Windows. So when any threats released, any virus released, directly attack the Windows first. But Linux is more secure. That is why most of the servers we use Linux only, right? So in real-time projects, we don't see any Windows servers. Very few servers, right? Yeah. So here multiple users can, multiple users can perform multiple tasks at a time. For example, in Linux servers, while deploying the code, so developers will log into the servers, testers will log into the servers, DevOps engineers also log into the servers. They perform multiple activities at a time, right? So Linux systems allow you to log in. Multiple users can log in at a time into the Linux servers, right? They can perform multiple tasks at a time. Fine. Any questions here? Anyone? Fine. So next one, networking will start tomorrow. So networking is very, very important, right? Yeah. So and few announcements. So already 3 demos completed, right? So whoever not added into WhatsApp group, you can add today itself. So today we allowed same meeting link, right? So tomorrow it will not be allowed, right? So whoever not registered so far, you can register today itself. So tomorrow onwards, the link will be changed, right? So even classroom guys also you can register today itself, right? So tomorrow onwards meeting link will be completely changed, right? So because slowly we enter into cloud, right? Already 4 days allowed, right? So you can clear the fee by today, EOD, and send me the screenshot so that we'll add into WhatsApp group. Already in the WhatsApp group, 20 people are available. We are like 19 or 20, right? So WhatsApp group created here. for our batch. It is 63 batch, right? Our batch is 63 batch. The 63 batch already 19 people added. Whoever not clear the fee, you can clear by today itself and send me the screenshot so that you will be added into WhatsApp group. Here already 19 people already added here, right? So you can add today itself.
By paying fees only, you can add the.
Exactly. Yes.
Okay, okay, sir.
Yeah. Once you make the fee, you can send me the screenshot so that you will be
Yeah,
added into WhatsApp.
yeah, okay, sir.
Fine. So if you have any questions, if you want to talk to me, so I give my number. Already I shared my number in the WhatsApp group, right? Yeah. I give my number. You can take down 96422111711. This is my number. So whoever joined newly today, you can share your WhatsApp number and email address so that we'll share the demo links, demo videos, and course content. So if any documents we share to you. Can you share your WhatsApp number and email address in the chat? Go to meeting chat. Whoever joined today, newly joined today.
Sir, so where can do we have any separate link to pay the fee, or so how it will go?
I could not understand. Can you come again?
No, no, about the fees, right? So will we get the link to pay the fee?
Yeah. So you can ping me. I'll share with you.
Okay.
Yes, you can ping me. Take down my number and you can ping me. I'll share the payment details so that you can make.
Sure. Sure, sir.
Fine. Yeah. So tomorrow we'll work on networks basics and IP address, subnet mask, gateway, and load balancers. That is very, very important. That concepts are very important, right? So day after tomorrow, slowly enter into cloud. How to create AWS account, how to connect AWS account, right? So what are the services available in AWS? We'll walk through all the services day after tomorrow, right? So after that, Thursday, we can start working on cloud platform, how to create infrastructure, right? So from Thursday onwards, you need to practice. You require laptop to be practiced, right? So you can arrange. You require internet and laptop. That's it. No need to install anything on your laptop, right? So from Thursday onwards, whoever want to come to institute for practice, you can bring your laptop here. You can sit here. You can practice. So till 12:31, I'll be available. If you have any questions, you can ask me. I'll guide you while practicing.
So
So
one
from day
more
one,
thing,
Thursday onwards, yeah. Go ahead, please.
yeah, one more. As part of the classes, right? You are going to give some of the assignments as well for us practice.
Yes, definitely. I give
Okay.
assignments.
Yeah. Thanks.
Right? Yeah. So everyone should practice from Thursday onwards, right? So make sure from day one you need to practice so that within 2 months, I'm guarantee you can easily crack your it. Fine? Yeah. Any questions, anyone? Anyone having any questions here?
Sir,
Fine.
you
So we
told us
stop
you
here.
will be also providing this study materials regarding this sections.
Yes.
Will you provide
Yeah.
the according to the sections, or else before the sections you will provide us?
Once we start working on AWS, once we work on any service, for example, EC2 service we discussed today. So I provide EC2 document today, right? You can go
Okay,
through the
okay, sir.
documentation, you can practice. You'll be having a
Okay, sir.
recording as well as document so that you can practice.
Okay, sir.
Okay?
Okay, sir. Thank you.
So I shared my number here in the chat. You can take down. If you have any questions, you can call me, WhatsApp me, so that we'll discuss. Fine? Yeah. So we stop here. So tomorrow we'll connect at 8 sharp, 8 a.m. So link may be changed tomorrow. Make sure you can add into WhatsApp group. In the WhatsApp group only we share the link. Okay? Fine? Yeah. Thank you all.